All right, PreCal, let's take a look at this question here. So we are given, plot the given parabola on the axis, plot the roots, the vertex, and two other points. So first thing I would suggest doing is factoring out a 2 just to make this parabola a little easier to deal with. I can factor out a 2. So we're going to divide by 2. It's going to be with x squared. So this is nice because 2, 4, and 6 are all divisible by 2. So this is 1, 2, 3x plus 6 and 8 gives me 3402. Okay, so this is pretty rough. What you're gonna end up having to do is try to figure out what times what gives me 3402, and add subtract gives me 123. It would be fair game to do this on a calculator, but I want to show you a different method in case you're not given a calculator. What I would do is divide by 2 because you know it's divisible by 2. So 34 is 17. 34 divided by 2 is 17, so this is 1701. I know that 1701 is divisible by 3 because if you add up all the digits, the sum of the digits is divisible by 3. Now, can't think of a slick way of doing this other than just doing basic long division. So let's do that. So this is 3 and this is 567. Let's try, I think 3 again will work out because it's 18. So again, I don't know a slick way of doing this. I'm just going to brute force it. 6 is 20, I'm sorry, 8 is 24. My eraser is way too big. What did I say? 5, 1, 3, 2, 6. What did I say? 8 is 24. Okay. And so this breaks down to 3 and 189. Now, let's see about 189. 189 is divisible by definitely by 9. There's just some weird sort of lag going on here. Okay, divisible by 9, which is 21, and 9 is 3 and 3, and 21 is 3 and 7. So clearly what I'm doing here is I'm breaking it down to the primes. So this leaves me with 2 times 1, 2, 3. Sorry, 1, 2, 3, 4, 5 threes. 1, 2, 3, 4, 5 threes, and then 7. So if I write it as the primes, it makes it a little easier to figure out like what multiplies together to give me I'm going to get 123. So you're going to have to multiply groups. So my instinct says, look, 123 is a pretty big number. So we probably want to, let's start with something like half and half. So this is going to give me what? 9. 9 and 6 is 54. This is going to give me 9 and 3 is 27. 27 times 7 is 14. 14 and 4 is 189. Okay, so that's, and we're adding everything, so it has to be the sum. So that's not going to work. So I need more 3s. So again, let me just rewrite it. I'll do it in different colors. And we did 3 3s. So maybe something like that. Let's go a little crazy on the 3s. So no, it can't be that because that's too many 3s. Oh, so we have a problem here because look, if I go too many 3s, so this is going to give me, let me do it like this. This is going to give me 81. Let's see if I go 81 and everything else. So that we get, this is 9 and 2 is 18. 18 times 7 is 56, which is 126. And I know this is 81. We want 123. That's a little too much. Let's see here. Did I count this wrong? I think 81's supposed to work. Let's see here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so I counted wrong. I put one too many threes. Okay, so we should have one less 3. So let's see here. 3 and 7 is 21. 21 times 2. 21 times 2 is 42. There we go. And that gives me 123. So the idea here, and I apologize for making a mistake here, but the idea is that we want to pick values that are pretty close to each other. And by writing the prime factors, it allows us to see, hey, how can I get closer and closer? I realized here, and even if the numbers, this was actually just 9 times 27, you know it's not gonna work. So I knew I needed to change the game up. But by listing the factors, it helps us to do that. You can, of course, if you have a calculator, you can just do this on the calculator. It's really easy on the calculator. Excuse me. What I can do on the calculator is just go under y equals, and we'll just type the number 3402 divided by x. And if you look under table, and you just scroll, excuse me, you just keep scrolling until you find it, the value that works. So like maybe you got to add them, so you know you got to go far. So this is going to end up becoming, I think, what was the other one? 42. So 42 and 81 ends up working. You just have to scroll. Now, keep in mind too, you could always just graph it. Excuse me. And then you can just, let's go zoom fit. Zoom fit's nice because it makes it fit, and then we can you can, well, if I go shift trace here, find the 0. This is the most dysfunctional problem I've ever done in my life. Okay, go to a point to the left, go to a point to the right, enter, enter. Let's try this again. So, well, we're saying it crosses at, it would be negative 81. So, let's see here. We could do it on the calculator. Apparently, this is not working out very well. Let me do it. Let me do it like this. Let me pull up Desmos. Might be a little easier on Desmos. Yeah, I already had it done too. So you can pull it up on Desmos, and you can obviously clearly see the zeros. But if you're doing it by hand, this would be the way to go about doing it. Okay. All right. So any case, it's a long-winded way, very long-winded way of saying it's x plus 81, x plus 42. Okay. Now, if you want to find what's in the middle, you can use, don't forget we do have a way of finding the middle. It's negative b over 2a, right? And this, by the way, is just the front part of the quadratic formula. All right, so negative b over 2a is the front part of the quadratic formula. So you could use that, but what I'm going to do is look, we know that the zeros are negative x equals negative 81 and x equals negative 42. So we know it crosses at 81 and 42, negative 81 and negative 42. And so what I could do now, if I wanted to, is if I average these points, the vertex is in between these two values. So if I take negative 81 plus negative 42, and just divide by 2, this will give me the middle point, which ends up becoming negative 61.5. Okay, so the x component of the vertex is negative 61.5 because, so like, let's say that this is like negative 81 and this is like negative 42 here. Going right down the middle would give me the x component of the vertex. Now, to find the y component, you take this value, you substitute it back in here and here, and it'll give you the y. And so if you do that correctly, you end up getting negative 760.5. That's our y component value. Okay, and I would say vertex and 2 other points. So if you, whatever you want to do for your 2 other points, you just plug in random numbers and you get them. But your graph, well, I graphed it on Desmo, so I'll just pull that back up. Your graph is going to look something like this. Okay. This question is talking about scaling. So scaling, you probably want to make what? If this is like 760 for the y, you probably want to make the y's in terms of hundreds. You probably want to make the x's in terms of tens. Okay. All right. So hopefully that was okay. I know there's a lot of math, a lot of talking there, but hopefully that's okay. And I'll find you guys in the next math video.